I want to go over how you come up with the formula for compounds that contain a metal that can form more than one kind of ion. So if you're given the name of that compound, how do you come up with the formula for it? And then conversely, if you're given the formula for one of these compounds, how do you figure out what to call it, what the name of it is? So first, I've got a few problems over here on the right uh, where I'm giving you the name, and you should figure out what the formula is. So this first one is copper 2 chloride. So first thing to do is just write out the symbol for the two elements that are in the compound, and that would be copper and chloride, or chlorine. So now the name of this thing, it has copper 2, so that means that this is just going to have a +2 charge, the copper is. So that's going to be 2 plus. Chloride is one of the halogens, so it is in group 7A, and the elements in group 7A always form a -1 ion when they form ions. So here's the situation. We've got copper with a +2, chlorine with a -1. So that's not balanced. There's more positive charge with the copper than there is negative charge with the chloride, and it's just a 2-to-1 ratio. So the solution to that is you want to have two chlorines, so that now you have a 2 minus charge. 2 times -1 is -2, and that's going to balance out the +2 charge on the copper. So the formula for copper 2 chloride is just going to be CuCl2. All right. Next problem: cobalt 3 oxide. So again, just write out the elements. Co and is cobalt, and oxygen oxide is O. Now, Roman numeral 3 here tells us that the cobalt's going to have a +3 charge, and the oxygen, being in group 6A, is always going to form a 2 minus ion, an anion. Okay, now this one is a really good example of the simple crossover technique that we talked about. So you take the 3 that's here for the positive charge on the cobalt, and you're going to move it down here, and it'll become the subscript for the oxygen. And then likewise, you take the 2 here for the oxygen, and it's going to come down here and be the subscript for the cobalt. So the formula for cobalt 3 chloride is CO2O3. CO being cobalt, not carbon and oxygen, but cobalt. All right, now the last one of this set is lead 4 sulfide. So lead is Pb, okay, and then sulfide is sulfur S. So we got the Roman numeral 4 here. That means that this is going to be a 4 plus charge. And sulfur. Sulfur is just like oxygen, same group, group 6A, so it's going to take a 2 minus ion. Now, just basic situation here is you've got a +4 and a -2, so in order to get this -2 to balance out the +4, we're going to have 2 sulfides. So 2 times -2 is a -4, and that's going to balance out, cancel out that +4. So the formula for lead 4 sulfide is just going to be PbS2. This one's a lot like one that was on your quiz, which was 10,4 oxide. Okay, so 10,4, that means the 10 is going to be 4 plus, and oxygen, as we've established up here, is going to be 2 minus. So that means that to get the +4 on the 10 balanced out with negative charge on the oxygen, you're going to have to have 2 oxygens. So 2 times -2 is -4, and that balances out the 10. So the formula for 10,4 oxide is just SnO2. Okay, now for the second type of problem that you might run into, you're given the formula, and we need to figure out what to call this stuff. So in this example, we've got CrCl2. So Cr is going to be chromium, and Cl is chloride. Now the only thing we got to do is figure out what the Roman numeral is that goes with that. So now you've got to look at the anion to figure out what the charge is going to be on the chlorine, on the chromium. And the anion here is chloride, and we've already established up here that chlorides always are -1, right? And we've got 2 of them, so that means this is going to be 2 minus, and to balance that out with the chromium, there's only 1 chromium, so it has, whatever the charge is, it has to totally balance out the chloride, so that means it's going to be chromium 2, because you're going to need a +2 to balance out the 2 minus on the 2 chlorides. So that's just going to be chromium 2 chloride. Alright, now let's go into one. This one's a little more complicated. Fe is iron, and SO4 is one of the polyatomic anions that we've run into, and that is the sulfate ion. Now, sulfate, if we look at our chart, is going to have a -2 charge on it. And, ooh, there's 3 of them. That's interesting. So there's 3 of them, times 3. So that's going to be -6 altogether. Put a little equal sign there. So the anion here, the sulfate, has a total of a -6 charge. So that means the iron's got to have a -6. Now, we know that whatever the charge on each iron is, there's 2 of them, so we have to keep that in mind. So we can go ahead and put a 2 up here, and basically it's just really pretty simple. What times 2 is equal to +6, because you got to balance out that -6 on the sulfate, so it's going to be 3. Now the 2 is coming from the subscript here, right? So that means the 3 has got to be the charge. So 3. So that's iron 3 sulfate is what this stuff is. Okay, so one last one. Okay, so this is tin oxide. Also, you could practically look at the chart here. There's 2 forms of tin. There's tin 2 and tin 4. But let's just kind of go through the reasoning on this. And okay, so this is going to be tin oxide. Okay, we got to look at the anion first when we're trying to figure out the naming of this thing. Oxygen's going to be 2 minus. And notice in this formula, there's just 1 of each. There's 1 tin and 1 oxygen. So that means that the tin has to balance out the oxygen, the oxide. So that means this is going to be 2 plus. It's a tiny 2. But, so we'll just put the Roman numeral 2 there. So that's tin 2 oxide. And that's how you do those. Basically, on these guys with the, when you're naming them, you establish what the 2 elements are, and then you've really got to look at the anion to get the clue on what the charge is on the cation.